Hello everyone. Now two polymers left. Earlier we have started with some important polymers, and out of that two polymers left. One is nothing but neoprene and second is nothing but viscous rayon. So with that we will end with some important polymers. So let's start with neoprene. So what is neoprene? It's basically the synthetic polymer, and it's a what we can say condensation polymer of 2-chloro-1,3-butadiene, that is chloropene. Okay, so as we have seen earlier, we have seen isoprene, right? It is 1,3-butadiene. Similar to that, there is 2-chloro-1,3-butadiene, which is nothing but chloropene, and that chloropene is taken as a starting material or as a monomer. It is then subjected to polymerization, and on polymerization it turns into formation of a neoprene. Okay, so let's see the we will go through the formation of neoprene. See, this is neoprene formation. So you will write title as neoprene. Okay, in that first write down it is condensation polymer. It is synthetic polymer. It is synthetic rubber basically, and it is a condensation polymer of 2-chloro-1,3-butadiene, that is chloropene. Then second write down it is resistant towards spatially the petroleum and vegetable oils, then light as well as heat. And therefore on basis of such properties, in third point you will write it is used in making hose pipes for transport of that whatever gasoline, and making gaskets. So that is third point. And fourth is it is used for manufacturing insulator cable, then jackets, then belts for power transmission and conveying. Okay, so these 4 points you are supposed to write after the title neoprene. Then start writing reactions. See, it's N mole of 2-chloro-1,3-butadiene. So at second position there is chlorine, so we have written 2-chloro, and at first and third position there is a double bond, therefore we have written 2-chloro-1,3-butadiene. Then on polymerization it results into formation of polymer like this. See, the double bonds are present in between this now get shifted in between this. Okay, and this double bond now it is utilized for new bond formation, that is this newly formed bond, and this is nothing but newly formed polymer. Okay, and it is so called as neoprene. So this is first reaction you are supposed to write. After that, once that neoprene rubber so formed, it is sent for the vulcanization process, and vulcanization is carried out in presence of magnesium oxide. Now how that vulcanization takes place, that we will see. See, CH2, so I have taken this one same polymer, CH2, CCl, double bond CH, CH2. Okay, same repeat unit I have repeated over here. Again same unit we are supposed to write over here, the same unit. Then same again downside again I have written that same polymer. Okay, and in between that I have written MgO and MgO. So vulcanization is carried out in presence of magnesium oxide. What will happen? See, chlorine is though present over there, that react with this oxygen from upside as well as downside. Okay, like this. Okay, and it results in removal of MgCl2, so magnesium chloride will be removed, and that oxygen will form a cross-link between these two chains. So this is one polymeric chain I have written as it is to that of the earlier. The second polymeric chain I have written similar to that of the earlier, and in between them this oxygen will form a cross-link. Okay, so that is so called as vulcanized neoprene rubber. So clear? So for writing neoprene, you are supposed to write this much along with those 4 points I have told you earlier. One is it is a synthetic rubber, and it is a condensation polymer of chloropene, that is 2-chloro-1,3-butadiene. Second, you will write it is resistant towards the petroleum and vegetable oils, heat and light. Third, you will write it is used in making hose pipes for the transport of gasoline and making the gaskets. And fourth, it is used for making the insulator cable, then jackets, then transmission line, power transmission, belts for power transmission and conveying. So these 4 points you are supposed to write, and all those 4 reactions. Is it clear? Next you will write is something about a viscous rayon, the 10th polymer. Now viscous rayon, it is basically obtained from cellulose, which is nothing but wood pulp, and that wood pulp is converted into viscous rayon. So cellulose, it is the what we can say linear polymer of a glucose, and it's said to possess formula C6H10O5N. So that cellulose is taken, or wood pulp is taken, that is allowed to react with NaOH first, it results in formation of alkali cellulose. That alkali cellulose then allowed to react with carbon disulfide CS2, which results in formation of cellulose xanthate. That cellulose xanthate on hydrolysis turns into formation of that whatever cellulose filaments. Okay, that is nothing but viscous rayon. So we will see that reaction part, and then we will proceed with further biodegradable polymer and the molecular weight of that polymer, or what is degree of polymerization and all that. So let's finish with that viscous rayon first. So this is something about neoprene. Then we will see viscous rayon. Now let's start with viscous rayon. What it is basically, as I told you earlier, the first point while writing viscous rayon, first you will write, or you will mention this as a title, viscous rayon. Okay. Next to that you will write cellulose, that is a wood pulp. It is converted into viscous rayon. Cellulose, it is the linear polymer of glucose, and it's said to possess formula C6H10O5N. Okay. So these 2 points you will write. First, cellulose, that is wood pulp, is converted into the viscous rayon, and in second point you will write the cellulose, that is the wood pulp, which is the linear polymer of a glucose and said to possess formula C6H10O5N. Okay. After that, start writing reactions. Okay. What you will write first, cellulose, that is wood pulp, it is then reacts with Na oil, that is alkali, and it results into formation of alkali cellulose. That alkali cellulose on treatment with CS2, that is carbon disulfide, results into cellulose xanthate, which on hydrolysis gives you viscous rayon, that is regenerated cellulose filament. This much you are supposed to write. So in third point you will write in what way that reaction takes place. Okay, in first point you will write it is a cellulose, that is a wood pulp, it is converted into viscous rayon. In second point you will write cellulose, it is a linear polymer of glucose, and it's said to possess formula C6H10O5N. And in third point you will write cellulose, that is the wood pulp, it is allowed to react with alkali, which will give you alkali cellulose. That alkali cellulose allowed to react with CS2 to give cellulose xanthate, which on hydrolysis gives viscous rayon, that is regenerated cellulose filament. Okay, so now we will see. So after this point you will start writing reaction. So let's see now how those reactions takes place and what way. Okay, see, cellulose, it's a hydroxy form, therefore I have written cell OH. Okay, so instead of writing that whole formula for cellulose, I have written cell OH, which is allowed to react with NaOH. So what will happen? That H will be replaced by this whatever Na, because both are cations, and therefore I have written cell. Okay, this cell, this O minus, and this is Na plus, and water will be removed. Okay, so it will give you what? It will give you alkali cellulose. Once it is over, then that alkali cellulose is taken and it is allowed to react with CS2. Now that CS2 is there, na, that's said to possess this kind of structure. Okay, like this. Okay, so how it will add? It will add across this Na plus. So this cell as it is, this oxygen as it is, and in between these two, that CS, that is CS2, undergoes addition, and therefore it becomes C double bond S as it is, and that negative charge now shift over the sulfur, and therefore it becomes NS minus and Na plus. Now this is called as cellulose xanthate. That cellulose xanthate, that is this, it is in hydrolyzed, that is H2O plus, and it results into formation of that whatever. See what happened over here, instead of H2O, that H plus will get get replaced by that Na plus. So cell or this oxygen as it is, this C double bond S as it is, this S as it is, but instead of Na, now I have written H, right? And that Na will go with the hydroxyl ion, and therefore it results or regenerate that NaOH or alkali we have used in step 1. Okay, so now whatever that structure so form or the compound so form, it's on further hydrolysis will give you. So whatever this part is there now, that will be removed. That okay, that CS2 will be removed or it will be regenerated, and that on hydrolysis that OH will go with this, and therefore it results into formation of cellulosic form again, but now it is called as viscous rayon, and it is nothing but regenerated cellulose filament. Is it clear? So which indicates the way by which that formation of cellulosic filament takes place. So with this we have done with important polymers. Now we will start with method that is the molecular weight or molecular mass and degree of polymerization of that polymer.